Okay, we're adding some other channels to the stream and recording. All right, we should be live here. Got a few different things going here this morning on our interview. Let's see. Let me pull up my notes. All right, so welcome back to another episode here at Composites Weekly. So be patient, everyone. If you're on the if you're actually looking at the live stream, I'm adding some channels here, and we're getting situated with my guest this morning. Let's see. All right, we're set to go. Today's episode is made possible today by the ACMA's Education Hub. It's the industry's destination for composites resources like CCT training and testing, recorded webinars, conference proceedings, regulatory information, customized manufacturing training, and much, much more. You can learn more by going over to acmaeducationhub.org. That's acmaeducationhub.org. If you have members of your organization, that needs CCT training, that's the place to go. I'm excited. We're going to have some updates next week on our program. We're going to have Kyle Jordan joining me on. He is the director of certifications. He's going to be joining me on. So we've got some updates there. But as always, if you have members of your organization that you want to have them trained, they need to get their CCT certification. That's the place to go. They have CCT programs for just about every application in composites you can think of. So, and of course, if you have questions, if you have specific training needs for your organization, you can reach out to them over at cct@acmanet.org. And if you have specific training needs or material quotes. All right, so I've got my guest on joining me today. He's getting set up. I've got Tyler Alvarado. He is the CEO of Continuous Composites. This company is on a journey to transform manufacturing. Really excited to have these guys join me this week. Continuous Composites began with a stab of fiberglass and a realization that composites manufacturing was a problem waiting to be solved. Their vision is to break the mold of additive manufacturing and advance new platforms and processes using composite materials. So I'm excited to have Tyler join me. He's going to be sharing some stuff that they're doing. If you have a chance, you should check out his TED Talk, by the way. I know it's a couple of years old, but it's really good. And happy to have him joining me. He's set up now, so I'm going to bring him in and welcome him on to the show. Tyler, thanks for joining me, man.
Thanks for having me, Jonathan. Happy to be here.
Absolutely. Glad you could, man. Glad you're set up. So we're going to be discussing some really fun stuff this morning. I think I've got the screen. You can find them continuouscomposites.com. Before we jump in, Tyler, why don't you give us a little background on yourself in the industry, and we'll get into Continuous Composites.
Yeah, awesome. Well, happy to be here with you guys today. So educationally, I'm trained in a business background, undergrad in accounting, MBA, CPA. I'm a serial entrepreneur. I've, been part of, growing, building, and selling businesses basically my entire career. I like to say more lucky than smart. I was planning to go be an investment banker, and I graduated during the 08-09 credit crisis and found my way into private manufacturing as opposed to investment banking. Nothing against investment banking. I have great professional relationships with many of them. But I really found my passion in entrepreneurship. Started Continuous Composites with the original inventor of the technology, ready to disrupt the way you manufacture a composite using an additive process. And so we've been building this business since 2015 and excited to share some of the progress we've made over the last 8 years and kind of where we're at and where we're going.
That's awesome, man. And again, continuouscomposites.com is where you can learn more. Let's talk about the what you call the CF3D or continuous fiber 3D technology. If you could give us an overview of that and how that works from like the way traditional 3D printing. We all know about additive manufacturing and some of the benefits, but there's also like, you know this as well as anyone who's been in this industry and has worked with this technology for a long time. There's always the people talk about the benefits of additive manufacturing, how it's going to revolutionize everything, but there's also some deterrents that are a lot of times, oftentimes not. I mean, they're not mentioned. So, but this is completely different. This is incorporating, obviously, composite application into that additive manufacturing process to offer a much more durable part. And there's a lot of advantages that we'll get into and talk about, but I want you to kind of give us kind of the foundation of the CF3D.
Yeah. So, the technology started back when we had some experience in composites, experience with additive. Everybody knows that composites are really high performance materials and lightweight, but it's the manufacturing constraints that really limit their uses. You're limited to basic geometries, molds, ovens, autoclaves, a lot of material waste. And so for that reason, you see the cost per pound of a finished composite part being very, very high. And oftentimes, that's the barrier to entry to use these high performance materials to kind of lower end applications. And then additive manufacturing is this general term that describes, starting with nothing, adding material to create a three-dimensional object, started with a lot of plastic. And so back in 2012, when this technology and this, coined trade name CF3D was invented, it was this concept of taking a continuous fiber with a matrix material and additively manufacturing a part. So we have a very extensive patent portfolio on the technology. And as we were starting to form partnerships with various industry players and customers, we kind of honed in on our first embodiment of that intellectual property, which is what you see on the videos today, and you see what we're out there in the market commercially selling. I'm going to reach over here for a moment and just grab a couple show and tell pieces just to make visualize it. But our technology CF3D starts with a dry continuous fiber. You can take carbon fiber from Toray or Hexcel or any of the carbon fiber manufacturers, glass fiber, air mids, any sort of continuous medium. And then on our print head is a high performance, rapid curing thermoset resin system. And so what we're doing is we're combining the fiber and the resin in situ, we're consolidating it in situ, and then we're aiming our cure mechanism right after that point of discharge and starting that polymerization process, which allows that composite part to take its shape. So the three unique differentiators of our technology is in situ impregnation, in situ consolidation, in situ curing, which that is what gets rid of the needs for molds, ovens, autoclaves. And it really allows you to take a continuous fiber that's an anisotropic material and place those fibers in the specific directions of the stresses and strains that the part's going to see. And then you can remove materials where you don't need them. So we've all heard topology optimization and the way you can remove materials, but oftentimes that's for an isotropic material. And what we're able to do is manufacture these really complex organic geometries using an anisotropic continuous fiber. You can dynamically steer it at the toe level in all three dimensions. So, that's kind of the uniqueness to CF3D.
That's awesome. And, you talk about, I think you make a good point. I was watching one of your videos where you talk about people talk about they often refer to the expense, of materials like carbon fiber, but it's not so much the material itself, it's the process that you're seeing happen. I mean, when you're dealing with pre-preg types of applications, there's a lot of expense that goes in, but most of the expense is in the process and not the material. And I find it interesting, from your standpoint, what you're doing is taking a lot of the expense that goes into that process, and you're able to utilize it. You talk about, not just these types of technologies or these types of materials should not just be available in high performance applications, even though, we spend most of our time talking about, aerospace applications. these things can also be done for everyday types of applications or bikes, like really cool stuff that we can create every day, that the expense can be reduced if we do it a different way. So
Absolutely. Yep. I
yeah,
wholeheartedly believe that CF3D is going to democratize the use of these high performance composite materials to industries and applications that can't currently utilize them today due to the barriers to entry, whether it's a design constraint or a cost constraint, or otherwise. So, and
yeah,
then to your point about kind of weaknesses and limitations,
yeah,
CF3D really is, it's not going to be for every single part. Right now our CF3D enterprise system it's a single lane end effector. It can take various toe sizes, but you are depositing toes at the toe level. It's a very flexible fiber, so you can actually steer both in plane and out of plane. I'll show you on our 7th axis rotator. We can manufacture these isogrid structures, and these can be for if you want to have a wing skin that's thinner and then reinforced for stiffness with these open isogrid structures. Here, that is demonstrated on a flat panel.
yeah,
But our kind of right product and part size right now, I would say, is medium to smaller parts. Maybe call it a couple meters by a meter by a meter, or
right,
smaller. We are an industrial robot, and where you can really take advantage of that fiber steering when you're going to design the part for CF3D, as opposed to just doing a very basic geometry and wanting to do a hand layup process. So it really fits this niche. It competes with hand layup, and it's this blend of like hand layup, filament winding, AFP kind of combined into one. And it really is this gap between like AFP and hand layup, where you can lightweight the part, you can reduce part count, and you can really take advantage of the unique capabilities of CF3D.
wow. So talk about what you guys do. I mean, my understanding is you guys handle everything from the hardware to the software to the materials. So it's kind of a one-stop. Is that right? Am I getting that right? Where
Yeah,
you
so
guys handle everything from start to finish?
we're an OEM manufacturer and supplier. So we've developed
Yeah.
the technology, spent a lot of years, doing R&D to land on our commercialized system, which is called the CF3 Enterprise System. It's
Okay.
based off of an industrial 6-axis robot with Kamau. It has an infinite joint 6, and then we have automated tool changing. So it's a really high performance motion platform that's driven by an extremely high accuracy CNC controller through our partnership with Siemens. And then attached to that end effector is our CF3D single lane end effector. And that's where the fiber and the resin are on board. The fibers are off the shelf fibers, as I mentioned. So we have strong relationships with the fiber manufacturers. And then we have a strategic partnership, and they're also an equity investor with Arkema. And Arkema develops the rapid curing thermoset resin systems. As you know, there's no one size fits all material combination. And so we do a lot of R&D developing new resins that work with our process, that have various mechanical and thermal requirements to meet customers' applications. Right now, we have 2 commercialized resin systems available. And I like to kind of break it into 2 product families. One is PMCs, polymer matrix composites, where we're printing these really, high strength, high TG resin systems, similar to what you'd see with like an epoxy, a CFRP with epoxy. And then the other family of materials that we have developed and are commercialized is CMCs, ceramic matrix composites. And so we can do, carbon-carbon, carbon-SiC, SiC-SiC, and we're developing different resin systems and certifying different fibers, all with this same motion platform and print head. And then, as you can imagine, there's no software that knows how to, tool path this. And so we're really CAD agnostic. We can work with any of the traditional CAD softwares. You import your step file into our software called CF3D Studio, and our in-house software development team is developing Studio. And what this is doing is it's giving the user the ability to take that solid model and turn it into machine readable code that's going to be commanding the robot motion and the process controls. It takes inputs from the user as far as like stress and strain, and it comes up with the unique tool path. And then we have the ability to also then run that through some of the traditional FEA software tools out there to analyze how is this part going to perform, relative to how I want it to perform. You can iterate there until you arrive at your optimized tool path, which is then just posted to the machine, and you can print it. So what we're doing is we're selling the machine, which has software, and then the customers will purchase the resin systems either through us or through Arkema, depending on volume. Sure. They get the fibers from the fiber manufacturers, and then we have a whole host of training and support. We have an application engineering team that really helps our customers be extremely successful with applying CF3D for their applications.
Wow. So there's a lot of support that goes in. I mean, from start to finish. What are some industries right now? I mean, we talk about you were showcasing some things there. I mean, what are some industries outside of the traditional that we look at aerospace that you guys are looking into?
Yeah, I would say if you look at aerospace, that's aerospace and defense are like the center of. I like to think of it as a target, and that's the center of the bullseye.
Absolutely,
those are going to be the folks that are extremely familiar with composites, both the strengths and weaknesses, and can immediately see the value of a new process like CF3D. So of course, we've certainly focused and honed in on aerospace and defense, but not commercial aerospace, given all of the FAA requirements and things like that. We're really focused on, unmanned aerospace, defense aerospace, both for PMCs and CMCs. We've also been engaged with a lot of industrial customers in the energy sector, whether that's wind or power generation through steam turbines. So there's a lot of applications there. And then you can imagine that bullseye as you continue to go to the next layer. There's, sporting goods, and there's, construction industry and the auto industry. But, one of my approaches to the business is you got to aim at one pin down the bowling lane, knock one pin down to the next. And so
absolutely.
You be very disciplined not to just chase every shiny object.
Absolutely. There's a tendency to want to do that, for sure. Totally. And you got to stick to your, what do you say? What's the old say? Stick to your knitting.
Yeah.
But I'm always fascinated when I look at, some of the technologies out there, like say, the bike frames and some of that. I love the outdoor biking and things like that, just mountain biking and things like that. So I know that those are obviously areas of interest, and obviously areas that can certainly be improved, industries that can certainly be improved.
Yep.
And cost reduction, as we were talking about earlier, cost reduction can be dramatically reduced. I mean, the reduction of the price of these things can be altered, with using different applications and different ways of doing things that don't require as much cost and upfront cost to begin with outside of the materials, so.
Yep.
Well, that's fantastic. How big, in terms of your, I know you guys are located out in, what part of Idaho?
Yeah, we're in North Idaho in the city of Coeur d'Alene, which is up in that panhandle right between the Washington-Montana border. It's about a 60-mile stretch across Idaho right there. So at the bitter root of the Rocky Mountains.
Beautiful area.
Yeah, it's gorgeous. So we got a couple facilities here combined. They're right next to each other, about 15,000 square feet. And that's both our kind of R&D and our manufacturing setting. It's beautiful location, located in downtown Coeur d'Alene, a block up from the lake. So it's a really great spot, all 4 seasons. And I feel blessed to be building.
Done some snowboarding up in that, just north of you guys, up across the border in Washington, up there. So not far from you guys, probably about a couple of hours maybe. But that's a beautiful area up there. It's a great location. Are you originally from that area?
I am. Yeah, I'm originally from Spokane, Washington. And,
Yeah.
So Spokane, Coeur d'Alene are very, very similar, just different states.
Awesome. In terms of your team out there, I mean, how big, how big of a team and your facility, your R&D facility out there?
Yeah, so we're about 45, 50 employees. I'd say about half of that is engineering development, and
of course,
the other half of that is, the rest of the business, manufacturing, sales, marketing. We are selling direct to our customers at this point in time.
Yeah.
But yeah, I mean, it's a phenomenal team. It's exciting. We all feel blessed to be developing a technology like this disruptive, and having the opportunity to engage with, some of the, best and brightest engineers in the world. So it's a dream come true, honestly.
So how do companies out there, if they're listening to this, Tyler, if they're interested, where do they start? Do they, obviously they start with reaching out to you guys, but I'm sure that you guys welcome visitors to your facility. Obviously there's some things that happen. This is a significant investment on their part to move forward with. What do you tell companies that have an interest, or people that have an interest in looking or moving forward with this technology?
Yeah, so they can reach out to us via our website, or they can send an email to info@continuouscomposites.com. We will respond very quickly within 24 hours. Is typically our goal. And we'll set up an intro call with one of our sales directors, as well as one of our application engineers. And
sure,
on that initial call, we're really trying to understand who the customer is and how they want to apply the technology, and make it a good fit. And then
what they want to accomplish. Exactly.
Absolutely. But you're absolutely right. As the conversation progresses, we will bring them to Coeur d'Alene, and we will, spend a day here, full agenda, learning more about their business and their application, and educating them more on our technology, and really making sure it's a good fit, and ultimately leading with the actionable next steps. So we do have a side of our business that we call contracted services, where call it funded R&D / printing parts, but it's not printing parts as a service in high volume. It's more of like helping them buy down their risk before they adopt the technology.
I see. That's kind of a nice transition there. I mean,
absolutely.
It gives kind of a proof of concept. Obviously, hey, this is how it's done, and this is how you can apply it yourself moving forward in the future.
So we focus on just asking good questions and making sure it's a good fit for both parties.
Absolutely. Yeah. So, and again, where can I mentioned the website, continuouscomposites.com, for our listeners. And that's probably the best way to get started. They go learn more. There's a lot of great content, by the way. I want to mention that they can, some videos, they can get really a full education on the technology, and understanding, before they reach out. So I would encourage them to visit your website. We're going to have that on our show page notes for this week's episode. Tyler, it's been a pleasure. Thank you for spending some time with me today on Composites Weekly.
Yeah, Jonathan, no problem. And one more thing that I thought I'd just mention is we do pretty active on our LinkedIn, and you just kind of jogged my memory that we put a lot of white papers out on LinkedIn that people can look at. We're also doing a tech tour right now. We're going to different cities across the U.S. every 6 weeks. We'll be in Huntsville, Alabama, here in the next 4 weeks. So people can register for that. It's free. We bring a whole team and parts. And that's a great opportunity to learn more about the technology and engage with our team face to face.
Wow, that's close to me. I might look at the dates on that. I might be down there.
We'd love to have you.
Yeah, I would love that. And where can they can go to the LinkedIn page?
Yeah, on our LinkedIn is where we're doing a lot of promoting for registering for that that next city that we'll be at.
Okay, perfect. By the way, and you jog my memory, I got to mention we're actually should be streaming on Modulus this morning, which is a new platform. Well, we've been on Modulus, but this is actually the first time that we're streaming on Modulus, or should be. I don't know if we are, but I'm pretty sure we are. Thanks to Adam Arms out there for giving me some assistance this morning. And this is going to be kind of a new platform outside of LinkedIn and X and some of these other locations that we stream to. We're going to be on Modulus now as well. So just wanted to throw that out to you. And I don't know if you guys have a presence on Modulus, Tyler, but if not, you should. It's a growing platform for our industry. So I would encourage you to be there as well. And I look forward to sharing this information and heading over to LinkedIn, maybe getting signed up for it. I'll check the dates out. That'd be great to head down to Huntsville.
Great. Sounds good. Well, thank you
Hey,
so much, Jonathan. I appreciate your time, and thank you to all the listeners, and look forward to engaging with you guys further.
absolutely. Hey, have a great weekend, Tyler, and just hang tight. We're gonna. I want to talk to you after we close out the show. But to all of our listeners, you can find us over at Composites Weekly. You can find us on our Modulus channel. Right now, it's growing. I think we're up to close to 500 members on our the Modulus channel. So appreciate that. Thanks to all of our listeners, and we'll catch you guys next time on here at Composites Weekly. All right, let me stop the